Okay, quick video. Don't know if this is helpful, but I'm studying buoyancy and there's a lot of things involved with these buoyancy questions in the PADI instructor course. So I'm just going to go over it. Now that I think I have it in my brain, there's a lot of things. So I'm going to start with the most simple thing, which is, what is a liter? Which seems like, yeah, we know what a liter is. It's a measurement of liquids. But you can use liters to measure non-liquids, and that's called volume or displacement, which suggests the volume. So it's the same number, but anyway. So I think that was the hardest part for my brain. This is it. We're going to say 200 milliliters of water. And this fishing weight. How are we supposed to know the volume of this? We put it in there. And then we look how much it's gone up. Not much, because it's a small object. But basically, the difference between where the water began and where it is now, that's the displacement, which also you can use the displacement to express what the volume of that object is. Okay? So that, some people already know. Some people are like, what? Right, so here we go. When you're looking at buoyancy questions, first most important thing is to look at type of water. Is it salt water or fresh water? If it's salt water, we have this magical number, 1.03. Okay. The other thing you need to know is weight. What is the weight of the object? Weight is measured in kilograms. And some smart scientist obviously decided, whatever the difference here, let's say it was 1 liter of difference, which it clearly isn't, but let's say it was. This is fresh water. 1 liter of volume in fresh water is 1 kilogram. Okay? We're there so far? Because when things were being measured, they were being measured in regular water in labs, and that's how they measured volumes. Okay, fresh water, good. But most of the time, we're not in fresh water in diving, we're in salt water. So now we have to look at converting to salt water. So that's where we get our 1.03, okay? So if we're looking to get the weight based on the volume, in this case, if it was 1 liter, which it isn't, but if it was, it would be 1 kilogram. Whew, hope you're still with me there. Anyway, so 1 kilogram, great. So the kilogram is the downward force. Okay, we've got our object, which is this square. The downward force is the weight. The upward force is the volume. And if the weight or the downward force is greater than the volume or the upward force, the thing will sink. However, if the volume is greater than the weight, the object will float. Right, so displacement. That's why ships need to be in the water with air inside them. because the air is part of the volume, but it doesn't weigh anything. So that is the most basic stuff. And then we start getting into slightly more complicated questions, but we'll start with the easy one, which is if we're converting kilograms to liters in salt water, we have our magic number. And going from kilograms to liters, right? This is just a note to remember that this is how it works. Don't worry about that. Basically saying liter is 1 liter, kilograms is less. So, I don't know. I'm not sure that's helpful for anyone, but some people maybe. Basically, kilograms to liters, divide 1.03 to get your liter. Liters to kilogram, multiply 1.03. Okay, so I don't know if you're still with me there, but we're looking at factors that affect buoyancy. Weight of object, we talked about that. Displacement, which is volume. Fresh water or salt water. Okay, we've done that. Now we're looking at current state of the object. This is just a whole new thing now. And it's not that complicated if you didn't have all the other things. Right? Okay. So, current state, meaning, is it floating? Is it neutral? Or is it sinking? Basically, if it's floating, it's positively buoyant. If it's sinking, it's negatively buoyant. If it's neutral, it's just below the surface, generally. But not sinking and not floating, just staying at a state somewhere slightly below the surface, which is what divers want, basically. So, that means the reason why when we add water to our BCDs, or if we're trying to get something, if we're trying to get a sunken object to float, we add like airbags of some sort. There's different types because air doesn't have a weight, or bags of air in water don't have a weight, but they do have a volume, meaning you're increasing the volume but not increasing the weight. And I think that's the hardest thing for people to figure out. Yeah. Okay. So, now we're asking, is it neutral? Is it positive or negatively buoyant? Great. If it's neutrally buoyant, that means the volume and the weight are equal. Okay? So in fresh water, 1 kilogram, 1 liter. All right. Meaning, if I had measured this and it had moved by 1 liter, I could say this is 1 kilogram. Are you still with me? I don't know. I'm barely there. Okay, good. So we've got that. However, we're not talking about fresh water all the time. So, if it's in salt water, we now have to decide. Are we trying to figure out weight? Are we trying to figure out volume? Okay? So if we're looking for, again, liters, the volume, then we're taking the kilograms and dividing it by 1.03. Yes, that's right. Yeah, this is basically the same as this. explanation there, but backwards. Okay, so because we're trying to find something, not explaining. Anyway, whatever. Okay, so if we're trying to find this kilogram, we take the liter times 0.03 if it's in salt water. If it's in fresh water, it's much more simple because we don't need to do that. Okay, so that's that. I don't know how helpful that part of the explanation was, but now we're into the real questions. Okay, so we have 4 questions here. And we're looking at things that are negatively or positively buoyant. If we have the exact number of difference, we can figure out the missing thing, weight or volume. Okay, good. First question here. Object is negatively buoyant by 20 kilograms in salt water. The volume is 75 liters, so what is the weight? Yeah, okay. So that means if it's negatively buoyant, the volume is less than the weight. So we'll start with that. Here we have our 20 kilograms. It's less. It's, yeah. Oh, God. And so, oh, right. And we're in salt water. That's important. And then we're looking at, okay, so what is the weight? We have the volume, but we have it in liters. So we now need to first figure out what that volume is in kilograms. Because it's salt water, we have to multiply it by 1.03, which is 77.25. Okay. So that first we've got the volume in kilograms, 77.25. Right. But the weight is 20 kilograms more than the volume. That's why it's negatively buoyant, right? So what we have to then do is get our number here, which I've made into an A, plus 20. That gives us our weight, 97.25 kilograms. So let's do it with the opposite. We've basically got the exact same question, only it's now positively buoyant by 20 kilograms. Everything else the same. That means the volume is greater than the weight. Yeah. With me so far? The first part is the same. We're trying to figure out what's the volume in kilograms. 77.25 kilograms is exactly the same so far. Then we're looking at, okay, positively buoyant. That means this volume upward force is 20 kilograms more than the weight. Therefore, you subtract 20 this time, and you get your weight. 57.25. Yeah, okay, good. Now, let's reverse that. We have a question trying to find the volume, or the liters. So, object is negatively buoyant by 20 kilograms in salt water, and it weighs 75 kilograms. So now what is the volume? We're looking at, okay, this time, like the very first one, the volume is less than the weight. Great. That's why it's negatively buoyant. So now we need to figure out what the weight is in liters. Right. So, first thing we're going to do is the displacement, or the buoyancy displacement, which is 20 kilograms, negative, meaning this is 20 kilograms more than that. So if we take off the 20, we have our upward force or volume. So now we have 55 kilograms. That is our volume, but we don't want our volume in kilograms. We want it in liters. So now we have to divide by 1.03 because we're going kilograms to liters. And that's our answer, 53 liters. Okay, and then we have the exact same question here, which is the only difference is now it's positively buoyant by 20 kilograms. So we're basically looking at the same information, and the only difference down here is we're adding 20 kilograms to get the volume because it's 20 more than the weight. That's why it's positively buoyant. So now we've got our 95 kilograms, which is 75 the weight, plus the positive buoyancy. Divide that by 1.03, and we have our answer. So simple.